Today, Mars is a cold, dry world with a tenuous atmosphere only 1% as thick as Earth's. But in the ancient past, water flowed freely across the Martian surface, maintained by a thick, early atmosphere. Since it first arrived at the Red Planet in September 2014, NASA's MAVEN spacecraft has been studying how that atmosphere was lost to space, and with it, the water. Now, as MAVEN continues its mission, we can look back on its many remarkable discoveries during its first 10 years at Mars. In 2015, MAVEN observed the solar wind eroding the Martian atmosphere. The solar wind is a stream of electrically charged particles blowing from the sun. MAVEN watched as ions from the Mars upper atmosphere were accelerated by the solar wind's magnetic field and driven into space, confirming that this process has deeply eroded the Martian atmosphere. In 2017, MAVEN showed that a process called sputtering has had an even greater effect on the atmosphere. When ions from Mars get picked up by the solar wind's magnetic field, they can crash into neutral atoms at the top of the atmosphere, sputtering them into space. MAVEN measured present-day isotopes of argon, which can be removed only by sputtering, to determine that 65% of the noble gas has been lost over time. This allowed scientists to estimate the escape of other gases and determine that sputtering has been the primary mechanism driving the atmosphere into space. Later in 2017, MAVEN revealed a twist in Mars's invisible, magnetic tail. When the sun's magnetic fields reach Mars, they pile up and wrap around the planet, creating an induced magnetic field that is drawn out behind Mars like a comet's tail. The Martian crust also contains small pockets of its own early magnetic field, which rotate along with the planet. MAVEN discovered that when these two fields interact, they put a twist in the magnetotail, confirming model predictions. In 2018, a runaway series of dust storms created a dust cloud so large that it enveloped the planet. During this global dust storm, MAVEN observed an abrupt, unexpected spike in the amount of water in the upper atmosphere. It discovered that heating from dust storms can loft water molecules far higher into the atmosphere than usual, leading to a sudden surge in water lost to space. Later in 2018, MAVEN announced the discovery of a new type of aurora at Mars. The mission had previously observed auroras during solar storms after electrons from the sun struck the upper atmosphere, causing it to glow with ultraviolet light. MAVEN's 2018 discovery was the first observation of a Mars proton aurora. When protons from the solar wind pick up electrons from the Martian ionosphere, they can slip through the planet's bow shock and plunge into its upper atmosphere, causing widespread auroras. On Earth, proton auroras are isolated near the poles, but on Mars, they can bathe the day side in ultraviolet radiation. In 2019, MAVEN produced the first map of wind currents in the Martian thermosphere, revealing disturbances in high-altitude winds caused by terrain features on the surface. MAVEN sensed these disturbances as it skimmed through the upper atmosphere, feeling the imprint of mountains and valleys far below. In 2020, data from MAVEN led to the creation of another new map, showing the Martian atmosphere's electric current systems for the first time. MAVEN detected these currents indirectly by observing the solar wind's magnetic field lines drape around the planet. Mapping the electric current systems can help scientists to better understand the forces